All right, so if we're looking at this problem, the cardinal number of each set, it's just asking how many numbers in the set. So in 7a, it looks like you did that one correctly. It looked like you had a lot of steps leading up to that. But really, the easiest thing to do is to go back to what we did last week when we were finding the sum of those sets of numbers. The first step that we had to do was to figure out how many numbers in that set. And what we did is we took that ending number in the sequence, and we did this two different ways. Sorry, you can probably hear my family in the background. We did this two different ways. We took that end number and subtracted the number ahead of that first term, which in this case is 200, and that's how we got 900. Or we did that end number minus the first number to get 899, but then we added that one back to get the 900. So you're correct in that first one, it is 900, and I know you know that, but anyway, just kind of wanted to show you the method that I'm going to use to get these other ones is similar to what we did last week. Anyway, so now B. Notice in B, there's a couple of different things you have to notice about B. It's different. We're going up by twos. It's odd numbers. And that's something that's really important to understand and to notice, because then there aren't as many numbers in the set. Okay, so there isn't 101 numbers in this set. So to figure out how many numbers in this set, we're going by twos, but this is our end number, is 101. So I've got 101, and one of the methods that I can use to figure this out is to subtract the term ahead of it. Well, the term ahead of 1 is not 0. It's actually -1. Okay, so I'm subtracting -1 here, not subtracting 1. Because we're going by twos. So the term ahead of this, the 0 term, would be -1. So we're subtracting -1. All right, so because of that, when you subtract a negative number, it actually ends up at 102. Okay, another method that I had showed you last week was to do 101, subtract that 1 gives you 100, but because, I'm not sure why my pen isn't working very well here, but because we're going by twos, we have to add 2 back, and that's how we end up with 102. Now, the next thing that we have to think about is the fact that we're skipping every other number. So we're not using a consecutive set of numbers here. So that means I actually have, I actually have 102 divided by 2 number of terms. I have 51 terms rather than the 102. So that's how we get to that 51. C, I really think your best bet here is to actually get all the terms from 1 to 1024, because what you're doing, and hopefully you're noticing this pattern. I'm sorry about all of this chaos happening in my house right now. My family is really loud. Noticing that we're multiplying by 2 every time to get to that next term. So just keep multiplying by 2 until you get to 1024, and you'll notice it does not take very long to get there. And then you can just physically count the number of terms. In D, notice you've got numbers from 1 to 100, okay? Those are getting plugged into this equation, yes, but really when you're plugging those numbers into the equation, you're still going to get the same number of terms as if you just counted the numbers from 1 to 100. Okay, so you can go back to this method that we used earlier to figure out how many terms are in that set. You don't have to worry about what is 1 to the third power, what is 2 to the third power. You can just deal with these because those are the numbers that are getting plugged in. That number of values that are getting plugged in for k is not changing the output, how many numbers in the set k to the third you end up with. I hope this helps. I know it was a little chaotic here. Let me know if it doesn't, and I can try something else. Thanks. Have a great weekend.